Intugent's ePU is a state-of-the-art digital work process for designing new elastomeric polyurethanes. It seamlessly integrates AI models and scientific models and provide guidance and predictions to scientists as they design new polymer. When ePU is first started, it displays the dashboard, also known as the R&D home. The dashboard displays studies or the datasets that we can work with. Here we can search for the datasets, create a new dataset, or work with an existing dataset. After we select the dataset, we go to the formulation page. It is on this page we design our formulations. We can also provide general information about the study. In the NCO index section, we enter the NCO index for each formulation in the study. We then specify composition of isocyanate blend. We can change the components of the blend. We can also specify composition of the polyol blend by selecting materials from the selection box. We can change, modify, or add components. As we make changes to a formulation or add new formulation, ePU performs a number of calculations instantaneously. Thanks to ePU's highly efficient algorithms and proprietary AI models, ePU calculates the weights of ISO and polyol blends needed for the formulation. It also calculates the material properties of the blends such as NCO content, OH number, and equivalent weights. Elastomeric polyurethanes contain hard and soft segments. ePU calculates the material properties such as glass transition temperature and solubility parameter of these segments. However, the real strength of ePU is the use of AI model to predict the final modulus and the confident limits. The model is trained using the data collected from the lab. The Properties and Data Files page allows the users to collect lab data and compare it against the predictions. ePU includes a very powerful proprietary AI engine. From the dashboard of SAI homepage, user can select the AI model to work with. On the SAI data analysis page, we can save info about the model. The data needed for training can be obtained by using a SQL statement or through a.csv file. Once data is ready, ePU calculates the correlation coefficients between the output variable and the input variables. We can also review the relationship visually between the output variable and the input variables. Note the ePU has already converted formulation information into material property descriptors such as glass transition temperatures and solubility parameters for hard and soft segments. This conversion improves the accuracy of AI models. After uploading the latest data, ePU is ready to train the model. For this particular model, we choose 2 hidden layers with 7 and 6 neurons. To test the AI model accuracy, the data is divided into training and validation datasets. We divide data into 5 buckets and use the first bucket for validation. Next, we want ePU to update the comparison between experimental and predicted data after every 200 iterations. We are now ready to press the Train Model button. ePU updates the left graph, showing comparison between the experimental and training data. ePU trains the model with more than 2,000 data points in less than 7 seconds on an average laptop. After training the model, ePU updates the comparison between predicted and experimental data for the validation dataset as well. A very powerful AI engine, visual feedback, and ability to interact with the model during training makes ePU the best in the industry. The AI module can not only be used to train AI model being used in ePU, it can also be used to train models using external data. ePU is a complete digital work process that seamlessly integrated various modules and can be customized to the industry needs. For further information, contact our customer support.